folks, I had a question coming out of section 7.3, number 13, and we're getting asked to solve this nonlinear system of equations here. And I say it's nonlinear because the x's, the x variables are squared and the y variables are squared. And I don't need both variables to be squared, but they just happen to be in this case. So nonlinear system of equations. I'm going to erase some of my markings. And if I also look, I'll switch over to my highlighter. I've got a positive 4 as the coefficient for the y squared and a negative 4 on this second equation for the y squared. So that's really set up well for elimination. You can see when I add them together, 2x squared, 4x squared, and then on the y squareds eliminate, and then I can simplify 4 minus 10 into negative 6, and there I go. Now, this is now a quadratic equation, right? So we're going to set it equal to 0, and you could either factor or use the quadratic formula. And in this case, I couldn't factor it. Well, no, I think that's a lie. I think I might have just lied to you. I could have factored it, but it looks like from my work, I opted to use the quadratic formula, right? And here, a would equal 4, b would equal negative 25, c would equal 6. And you can see my work there. And just so you're clear on how I got from here to here, right, the two answers are 25 plus 23 over 8, and then the other one is 25 minus 23 over 8. And 25 plus 23 is going to be 48 over 8, which is the number 6. And here, 25 minus 23 is going to be 2 over 8, which simplifies to 1/4. So those are my x coordinates, which is great. That's half of my battle. And then I need to substitute them back into either of these two original equations to solve for y. I obviously I can't see. I'll scroll down in a bit. My guess is I'm going to plug it back into this one, this first equation, just because it's a little bit simpler. So if I scroll down, yeah, there I am plugging both of these x values back into, and you can see it here. Here was the first equation, this graph of this ellipse. And so I substitute in, right? I'm going to start with the 1/4, and I'm going to put 1/4 in for x, and that's what you see going on right here. And when I do that, that's going to allow me to solve for y, right? So if we kind of play this out, right? 2 times, and let me PEMDAS this, all right? 2 times 1/4 squared is like saying 2 times 1 over 16 plus 4y squared equaling 4, right? So that's like saying 2 over 16 plus 4y squared equals 4, right? And because I want to show you how I get to this solution here. And then I would subtract the 2/16 over. So 4 minus 2 over 16, right? And so I'm going to simplify this a little bit more. So I'm going to have 4y squared. Now, if I want to get common denominators, this was over 1. So this is going to be 64 over 16 minus 2 over 16, right? So again, I got 4y squared as I start to work through this. This is going to be 62 over 16. And when I divide everything by 4, because I want to solve for y squared, right? I'm going to divide by 4. I'm ultimately going to get y squared is 62 over 64, which when I simplify is 31 over 32. So I know it looked funny to kind of jump from here to here, but that's what I was essentially doing. And then I can square root both sides, not leaving that radical in the denominator, right? I rationalize that rationalize that denominator, and there are my two y coordinates that go with the x coordinate of 1/4. And then I also, on this left side, I should have done it in the correct order, let me do the highlighter, for x equaling 6, when I plug it back in for x here, this one's a little bit nicer. When you solve for y, you get y squared is negative 17, which doesn't have any real solutions. So ultimately, I have two ordered pairs. I have 1/4 and then positive root 62 over 8 and 1/4 negative root 62 over 8. So those are my answers. All right, thanks so much. Bye.